All right, so 32 looks like this. We have 32. All right, so 32 is the tangent of pi over 2 minus x equals cotangent of x. They want you to prove this using your sum and difference. So if you go to your sum and difference, you're going to take your tangent and you're going to plug those in. So remember, when you're subtracting for tangent, they actually did it using quotient, which is a little bit easier. So tangent then is sine over cosine. All of the ones I give you, you either expand or condense, but they did it this way. This is fine. The sine of pi over 2 minus x over the cosine of pi over 2 minus x. What is the sine of pi over 2 minus x? Cosine of x. What's the cosine of pi over 2 minus x? What is cosine over sine? 2. All right, so bell work looks like this. We have the cosine of pi over 2 plus x minus the sine of pi over 2 plus x equals 0. All right, so far so good. What can we do here? You're a sum and addition, right? And so if I do this, the cosine is going to be cosine, right? So cosine of pi over 2 cosine of x minus, remember that one's minus, sine of pi over 2 sine of x, right? That's what this guy will expand to. And then minus, and then we have, this is going to expand to sine, cosine, cosine, sine. So sine of pi over 2 sine of x. And then we keep it a plus. Oh, no, cosine, sine, cosine. That's cosine. This is cosine of x. And then we add cosine of pi over 2 sine of x. All right? So far, so good? Let's fill in what we know. What is the cosine of pi over 2? Cosine at pi over 2? 0. So 0 times cosine, this is just going to be 0, right? Minus, what is the sine at? 1. That's 1 times sine of x, so we just get minus sine of x, right? So that reduces to that. All right, over here, sine of pi over 2, we just said was 1 times cosine of x. So this is going to be cosine of x plus cosine of pi over 2 is 0. 0 times sine is 0. All right, so we end up with negative sine of x minus cosine of x equals 0. So far, so good? All right, so here's what I actually do here. This might be a little bit different. I do it like this. I actually add 1 to the other side. So I actually would move this cosine over. So we would say something like negative sine of x equals the cosine of x. So where are cosine and sine the same number, but just opposite signs? That's all it's saying, right? They equal each other, but they're opposite signs. Yeah, it's wherever you have square root of 2 over 2, but specifically where one's positive and one's negative. At 45, they're both positive, so they're not opposite signs there. What quadrants are they opposite signs in? So, right, so we have this right here. We know it's going to be a 45-degree angle. That's where they equal. But here, they're both positive, right? Sine and cosine are both positive. Here, sine and cosine are positive, negative. So this quadrant, so that's 3 pi over 4, right? Here, they're both the same sign, right? They're both negative. So that's not going to be opposite signs. But here, they are opposite signs. This is what? 7 pi over 4. So that's where that occurs. When x is 3 pi over 4 and 7 pi over 4, they will be the same number, but just opposite signs. One's positive, one's negative, or vice versa. There are also times where you have something that the angle itself may not be something you can easily get to, but the double angle is, or vice versa. And so these double angles help you a little bit in maybe using what you know. If you just know the sine and you want the sine of the double angle, then you can go from there. By double angle, it's when you double it inside. So let's say the angle was 35 degrees. The double angle would be the sine of 70 degrees. You double it before you get it out of the sine, okay? You double it inside. So when I say double angle, I'm talking about the angle being doubled inside the trig function. Inside the trig function, all right? These are ones, again, that you just need to memorize, all right? They do come from your sum and difference. It's basically the angle plus the angle. So these come from the sum and difference, and we can take one just to show you. Like, let's take this for example, just to show you where they come from, but then you just need to really memorize them. The sine of 2 times theta. Remember, theta is just like an x. So we can say the same thing, sine of 2x. Let's write it that way so it doesn't get crazy looking. Well, I could write that as the sine of x plus x, right? Isn't that 2x? Yes? All right. Well, how do I expand that? Well, the sum says that's going to be the sine of x times the cosine of x plus the cosine of x times the sine of x. Well, aren't those the same thing? Everybody agree that those are the same thing? If I add 2 of the same thing, that's just 2 of those sine x, cosine x. That's what it says it equals. All right? So that's where they get it from. They get it from what we've already learned. That's where they come from. And that's what they just did there to prove it. That's what the proof says right there. All right? So sine is easy. The sine of 2x is 2 sine x cosine x. All right? Tangent. Tangent of 2x, that's 2 tangent x over 1 minus tangent squared. All right? You'll notice cosine has multiple options. All right? There are multiple options for cosine. And depending on what you have been given is what you will choose to use. All right? There are times when you can use different ones. Cosine of 2x can equal cosine squared minus sine squared. It can equal 2 cosine squared minus 1. It can equal 1 minus 2 sine squared. Why is it important to know these 3? Well, what if you just knew the sine? Well, then you would use the 1 minus sine squared. What if you just knew the cosine? Well, you could use the 2 cosine squared minus 1. Then there are times when you can replace it with the cosine squared minus sine squared, and it will help you solve it another way. Maybe Pythagorean identities will help you in there. All right? So let's look at the first example they give us here. If the sine of theta is negative 7 over 25 on this particular interval, find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Why did they give me this weird random interval? Well, what are they actually telling me about my angle? If I am going from pi to 3 pi over 2, what are they telling me? What quadrant am I in? Yeah, I'm right here. So that's what they're telling me, by the way. They're telling me I'm in that quadrant. Okay? Now that's where I start out in the quadrant, all right? So it's possible that doubling that angle is going to throw me somewhere else. Don't you think doubling that angle is going to throw me somewhere else? Like, let's say I doubled an angle, a 60-degree angle. Where would I be if I doubled that angle? 120. Well, that just bumped me into a different quadrant, didn't it? Does that make sense? And so there are going to be times when it throws you into a different quadrant. And so you'll notice that your values actually end up to be positive here when you do all of this, even though you started out in the third quadrant, which was negative. It threw you all the way around to a positive quadrant is what it does when you double it. All right? So they gave me sine, and they said find the sine of 2 theta. What do I have to find the sine of 2 theta? The sine of 2 theta is what we want to solve for first. And that is 2 times the sine of theta cosine of theta. What's the problem? They only gave me what? Sine. What do I need? Cosine. All right? I need the cosine. How do I solve for the cosine? There's a couple ways we can solve for the cosine, by the way. There's a couple ways. Pythagorean identity, sine squared plus cosine squared equals 1, right? We can go way back to our point on a unit circle. They've given us x and they've given us y and r, and we can use Pythagorean theorem to solve for x, right? So think about where we are. In fact, they give you a picture in the book. They've given you they've given you y and r, remember? Remember when we did this? So somewhere over here, they've given us r is 25, and they've given us our y value of 7. Everybody remember that?
Yes.
And so we can use Pythagorean theorem to solve for our x value if we want to. Either way, you're going to end up using Pythagorean theorem, whether it's through the identity, so sine squared plus cosine squared equals 1, or if you just use a squared plus b squared equals c squared. All right? You end up with the same thing. You end up with an x of 24, by the way. All right, so if we do this, we would say negative 7 over 25 squared plus cosine squared equals 1. All right, if we do this, we're going to end up with a squared plus b squared equals c squared. All right, which is 7 squared plus b squared equals 25 squared. 25 squared is 625. When you subtract that and then square root, you're going to get 24. So b equals 24. Over here, you're going to get cosine equals 24 over 25. I am in what quadrant? How do I know what quadrant I'm in? Third. So what is my cosine? Positive or negative?
Negative.
Negative. My cosine is negative 24. All right? So I did that just so I could plug it in here. They want 2 theta. That's what they're asking us for, 2 theta. Okay? So if I want 2 theta, I need my cosine to be able to do it. So I'm going to say 2 times my sine, negative 7 over 25, times my cosine, negative 24 over 25. All right? And I'm going to get this huge number. 7 times 24 times 2 is 336, and 25 times 25 is 625. And I don't think that reduces, actually, by the way. That is your sine. That is your double angle there. Now, cosine has 3 different ones we can use. It is cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. And honestly, because you have the same denominator, I think the sine squared minus the cosine squared is going to be the easiest one, believe it or not. All right. So, but either way, so with cosine, you have 3 different options. All right. So they also want this guy, cosine of 2 theta. All right. So you have 3 different things you can do. You can say cosine squared minus sine squared. You can say 2 cosine squared minus 1, or 1 minus 2 sine squared. Those are my 3 options. It does not matter which one you do. So let's say, that one's a hard one. Let's do sine. What do we solve for? Sine is 725. 7 over 25, so let's plug that one in. We're going to take what they gave us. 1, we're going to use this one. 1 minus 2 times negative 7 over 25 squared. That's 1 minus sine squared. All right, so if I do that, 7 squared is what? What's 7 if I square it? 49. 25 squared is 625, right? We know we're going to have to make that a common denominator of 625 over 625. 2 times 49 is 98 over 625. And what did they get? 527 over 625 when you subtract it out. So I have my sine of 2 theta is right here. My cosine of 2 theta is right here. All right? Tangent of 2 theta. Now, hang on. It doesn't say I have to use my double angle to do this. What is tangent? It's sine over cosine. All right, so look, tangent is just sine over cosine. So if I have my sine of 2 theta, which is this big humongous guy, over cosine of theta, which is this big humongous guy, let me tell you a little secret about keep, change, flip. When you keep, change, flip and you have the same denominator, it just ends up being numerator over numerator every day, all day. Okay? So when you keep, change, flip, what's really going to happen is this, and you're going to end up with 336 over 527. So in this case, you have the sine of 2 theta and the sine of theta. You cannot solve it this way. You have to think of those, even though they don't look like it, as 2 different numbers, because they are. It would be the same thing as if I said, oh, let's do sine of x minus sine of y. What do I do with that? That's 2 different angles, okay? And so you have to write them in terms of the same thing, or you cannot solve it, all right? And so before I can do anything, I have to rewrite one of these. Well, the only one that even can be rewritten is the sine of 2 theta. And so I am going to rewrite this sine of 2 theta, and I'm going to say, instead of sine of 2 theta, I'm going to say 2 sine of theta cosine of theta, and then I can say minus sine of theta equals 0. Now, all of a sudden, I have something that I might possibly be able to do something with, okay? What could I possibly do to solve this?
Take a sign out.
Yeah, factor. We're going to factor out a sine. So I'm going to take sine out here, and I'm going to be left with 2 cosine of theta minus 1. And now I can just set each group equal to 0 and do what I've done this whole time. All right, I can say, okay, sine of theta, and then 2 cosine of theta minus 1, and then solve them. What angle gives me a sine value of theta of 0 from 0 to 2 pi? Where do I have a sine value of 0?
0
on the unit circle. Yeah, at theta equals 0 and theta equals pi. Everybody agree? That's where I have that. All right, on the other side of this, add 1, divide by 2. I have a cosine equal to positive 1/2. Cosine equal to positive 1/2. Where on the unit circle do I have a positive 1/2 as my cosine?
Pi over 3.
Yeah, 60-degree angle and positive 1/2.
And the bottom at 5 pi over 3.
There we go. Those are my answers.
0
Those are my answers.
to